Alright, you guys, so now we're on to a brand new factoring technique called a difference of two cubes. Now, what this states is when you have two perfect cubes that are subtracting. So what a perfect cube means is this is a number where you have three of the same exact number that multiply to equal it. An example of this is 8. 8 is a perfect cube because, so if I have like 8 equals 2 times 2 times 2. So perfect cubes require 3 of the same number multiplied to itself. Okay, so if you see two perfect cubes that are subtracting, you can factor using a difference of cubes. So it's a formula. What we're going to do, we're going to take the cube root of each term, which I'll explain how to do that. And that will give us our A and our C. And the formula will be A minus the C. Then we're going to square the A, multiply the A to the C, and then add it to the C squared. So this is the formula after we cube root each term. Now something you have to be careful with. In order to use a difference of two cubes, first of all, you must have two terms. If you see, all these have two terms. So you can only use this factoring technique if there are two terms. So there are two terms, they are subtracting, and you have to have perfect cubes. Okay, now the difference between this and a difference of squares has to have two perfect squares. So two things that multiply to equal a number. So an example one is like 9, which equals 3 times 3. So that's a difference of squares. 9 is a perfect square. 8 is a perfect cube. So a difference of two squares, although we do have two numbers that are subtracting, like in a difference of cubes, difference of squares has to have a perfect square. Difference of cubes has to have a perfect cube. So they're kind of similar, but we just have to know the difference because on the test, I'm not going to tell you which factoring technique to use. All right, now, whenever we start factoring, we always look for the GCF first. The GCF always makes our equation smaller, which is easier to work with. So let's see here. Do you guys see anything in common between each of these terms? So any variables that are the same? Oh man, you guys spotted it, the x's. Okay, so the GCF in this one will be x for sure. So now I'm going to have an x for my GCF. And remember, I need to grab the largest amount of x's and the same amount of x's from each term. So if I grab the same amount of x's from each term and the largest amount, they both contain two x's. So this will just be x squared. I can pull 2 from each since each of these x's have two x's with them. Alright, so let's start by factoring out our GCF. Let's see what we have left. Okay, I'm going to divide each of these by my x squared. Okay, which the x squareds in both terms will cancel out. So we're left with a to the 6 minus b to the 6. Okay, now, when I do my difference of cubes, I'm now looking at only this parenthesis and nothing else. Okay, which, let's think about it, okay? I have to be able to cube root each of these terms. So let's see if we can. In order to get the A and the C in this formula, guys, we must cube root each of these pieces. So to get the A, we're going to cube root the first term, which is A to the 6. In order to get the C, we're going to cube root the second term, which is B to the 6. All right, let's see what happens, you guys. So when we are taking a cube root of a variable with an exponent, this only works with variables with exponents, not with numbers. I can't use this on 8, for example. You divide the exponent by the index number, which the index is going to be a 3 in a cube root. Okay, so 6 divided by 3 is 2, so this will be a squared. And 6 divided by 3 will also be 2, so this will be b squared. Okay, guys, so this is my A term, and this is my C term. All right, so I can cube root each of these. So I have two numbers that are subtracting, and I can cube root them. So I can use this difference of cubes up here. So let's write our final answer, you guys. So my formula says to subtract the A and the C. Well, this is my A and my C, so I'm going to subtract the A squared minus the B squared. And then it says I'm going to square my A term. So my A term is A squared, and I will square it, okay, then plus A times C. So I'm going to multiply my A to my C, so A squared times B squared. Then the last part says to square the C term. So I'm going to square my C term, which is a B squared. Okay, all we gotta do now is simplify, you guys, and then we're done. So we just gotta simplify and we'll be done. Now the first term's already simplified, so I'm just gonna bring it down. A squared minus b squared. Alright, when you have an exponent beside an exponent, this is not a squared raised to the second power, it's a squared, and then the 2 is sitting right next to the 2. So when we have that, you guys, what we do is we multiply those together. So I'm going to be multiplying the 2's. Okay, so a squared squared is a to the 4th. Okay, then a squared times b squared is a squared b squared. And then b squared squared, I multiply these together because I have an exponent beside an exponent, which would be b to the 4th. And that's it, you guys. We factored using a difference of cubes. Holy hot dog, wasn't that fun? So that's my answer. Alright, now the second one is pretty much the same thing. So if you feel like you have a good grasp on this, I would go ahead and try example 13 on your own. Otherwise, let's follow along. Okay, I'm excited, you guys. Alright, so first of all, if you see, I have 2 terms and they're subtracting. So this is telling me I can either use a difference of cubes or a difference of squares. Now, the reason why a difference of squares would not work, I'm going to explain. I can square root of 64. Okay, I can't square root of next to the 9th though because 9 will not divide by 2, so that one fails. And then this one also fails, you guys, because I can't square root of 125. Doesn't work. But I can square root of y to the 6th. But in order to use a difference of squares, you have to be able to square root each of these terms, and we can't. Okay? But maybe I could cube root each of these. So let's see what happens when I cube root each term. Okay. Which actually, before we do that, technically, I'm supposed to look for a GCF first, so I'm getting ahead of myself. Sorry, guys. So let's see if there's a GCF. Okay, let's look at the numbers first. Does anything go into 64 and 125? No, the only thing that goes into 125 is like 5 and 25. Okay, and that doesn't go into 64. So the numbers don't work, and I don't have any variables in common in each term. So there's no GCF, with that, which that is okay. All right, so what we need to do for this one, which actually, you guys, this one, geez Louise, this one, let's go back to this problem real quickly. If you have a GCF, you guys, technically it's supposed to go in the front, so don't forget about it. So technically this one would be x squared times a squared minus b squared times a to the 4th plus a squared b squared plus b to the 4th. Sorry about that. The GCF always gets left out, and if you see, even I forgot about it. Poor old GCF always gets left out. So if you guys ever have a GCF, try not to forget about it, and it always goes in the very front. Okay, sorry about that. I noticed that as I was solving this and I got sidetracked. Okay. Alright guys, so over here, again, there was no GCF. So now we're going to progress onto this phase, the A and the C. So the A, you're going to cube root the first term, which is the 64x to the 9th. And then we're going to cube root the second piece, and just like with a difference of squares, you guys, we ignore the negative when we do this. Okay, so do not even look at the negative. So 125y to the 6th. Okay, so the cube root of 64. I need something that multiplies to itself 3 times and gives me 64. Okay, which I know that it is 4. Okay, now, say that you don't know what the cube root of 64 is. I have something that can help you. Okay, so if you don't know what the cube root of something is, you guys, what you can always do is a factor tree. But in the factor tree, this time, since we're dealing with cube roots, instead of looking for 2 numbers with a square root, you are looking for 3 of a kind. So like, for example, 8 and 8 go into 64. 2 and 4 go into my 8s. And then my 4s break down into 2 and 2s. Okay, so 8 times 8, 64. My 8s break down into 2 times 4. And both of these 4s break down into 2s. So if you want to know the cube root of something, like before, we ignore everything that breaks down. Everything. So like my 64 I ignore. The 8s broke down, so I ignore those. And the 4s broke down. So all that's left is a bunch of 2s. But with cube roots, you're looking for 3 of a kind this time, not just 2 of a kind. So we need 3 people to go and leave the radical, okay? So for example, I see 3 of a kind here, and I see 3 of a kind here. Okay, so I have two groups of 2's, which means, remember you guys, for each group, 1 2 will come out. So on this one, a 2 and a 2 will come out. And remember, if more than one thing comes out, you multiply them together. And since nothing is left over, you guys, nothing is going to be in my lonely radical. Okay, so I don't have a radical because nothing's left over. And if it is a perfect cube, it shouldn't have anything left over because that means if it's a perfect cube, there is a cube root. Okay, so 2 times 2 is 4. Okay, so the cube root of 64 is 4. Okay, so if you don't know the cube root, you can always do a factor tree and look for groups of 3 instead of groups of 2. All right, well, let's keep going. Let's keep going. All right, and the cube root of x to the 9th, remember, when you have a variable with an exponent, you can only do this with variables with exponents. You divide the 9 by the 3. So this would be x to the 3rd. All right, and then over here, the cube root of 125 is 5 because 5 times 5 is 25, and 25 times 5 is 125. And then the cube root of y to the 6th, I divided 6 by the 3 and get y squared. All right, as the last step, we got to put it into our formula up here. So I have my a and my c. So the first step is to subtract the a and the c, which I'm going to write it down here, you guys, because I have a little bit more space. Okay, so I have 4x to the 3rd. I subtracted by the c, which is 5y squared. And then I need to follow the rest of it. So I'm going to square my a term. So I'm going to be squaring the 4x cubed term. Okay, and then it says plus a times c. So I'm going to be doing 4x to the 3rd times my 5y squared. That's my a times my c. And then the last thing, I'm going to square this final term. So I'm squaring my 5y. Which I know that's hard to see. That says 5y squared. Okay, so I just followed the formula, you guys. That's all I did. I'm going to zoom in so you guys can see this a little better because I know it's really small. Okay, so that is a 5y squared. I know it's hard to see. All right, so I'm going to bring this down. So I have 4x to the 3rd minus 5y squared. All right, now when you have more than one thing raised to an exponent, this is the same as raising each piece to the exponent. So this is 4 squared times x to the 3rd squared. So I'm squaring each of these pieces, okay? So 4 squared is 16. All right, next to the 3rd squared, we multiply those exponents together. So 3 times 2 is 6. All right, so that first term is 16x to the 6th. All right, now this next one, 4x cubed times 5x squared. Well, 5y squared. 4 times 5 gives me a 20. All right, I can't combine my x and my y, so it's just x cubed y squared. And lastly, my 5y quantity squared, this is like 5 squared times y squared squared. So this is y squared squared. Okay. So I got y squared and then raised to the 2nd power. Okay, because my c term is 5y squared and we're supposed to square the c term. So we're squaring a 5y squared. Okay. All right, so 5 squared is 25. And y squared, 5 squared is 25. And y squared squared, well, we multiply these two exponents together, which is y to the 4th. Okay, so basically if you have a square, just square each piece. 4 squared is 16. X to the 3rd squared, you multiply them, you get x to the 6th. 5 squared is 25, and then y squared squared is y to the 4th. And since I don't have any GCFs, okay, I don't have to write in front like on this one because there wasn't one. So this would be my final answer. Awesome job, you guys.